Good evening, everyone. Myself Gautam Sharma. I welcome you all in a Sapiens Education. So today I am going to discuss about the part two of the magnetism and matter. So here we will discuss about these things, magnetic dipole moment. So let us go for it. So what is magnetic dipole? So the word itself says that two pole. Dipole means two pole. So there will be a two pole. A magnetic dipole consists of a two unlike poles of equal strength and separated by a small distance. This. So let us suppose this is a south part and this is a north part, and here are how many poles? Two poles, and it is separated by the distance of 2L. So this 2L is known as magnetic length. This 2L is known as magnetic length. I hope you have understood this. Okay. So a magnetic dipole consists of a two unlike. So wherever you will find any two unlike poles like north and a south, and it is separated by a distance of any length, it may be 2A, 2L. So for sake of convenience only, we are taking as a 2L. So it is a vector directed from the south to north pole. So definitely you always try to remember that the direction of the magnetic dipole. So if you want to find a magnet direction of the magnetic dipole, so it will be from south to north pole. So see, this is the direction of magnetic dipole. I hope you have understood this direction of magnetic dipole. Okay. Now, what is magnetic dipole moment? So if you want to find a magnetic dipole moment, so its symbol is M. So it is the product of the strength of either pole and the magnetic length 2L. So I hope you have remembered that dipole moment of a charge. So if there was a charge, positive charge and negative charge, and it is separated by distance 2L, so the distance charge will be multiplied by 2L, so you will get dipole moment. But here we will discuss about the magnetic dipole moment. So in this, magnetic pole is involved. So let us consider magnetic pole having a pole strength of M. So this side also M, this side also M. The polarity is different, that is south pole. This side, this is your south pole, and this side there is a north pole. Got it? So finally, if you want to find a magnetic dipole moment, so this will be small m into 2L. So we have to take any one of the magnetic strength. So both are same, so you can take any one and should be multiplied by the total length between these two pole. So this is the magnetic dipole moment, right? And it will be always directed from south to north. It will be always directed from south to north. So I hope you have understood. Magnetic dipole moment is a vector quantity and its direction is from south to north pole. So I hope you have understood this magnetic dipole moment, right? So it is similar or analogous to the dipole moment, electric dipole moment. Now magnetic pole strength depends upon the nature and a cross-sectional area of the material. So we know that this m, small m, is the magnetic pole strength. Okay, magnetic pole strength. So its strength is directly proportional to the area. So if you increase the area of cross-sectional area, so magnetic field strength will also be increased. Okay. So magnetic field strength is directly proportional to the cross-sectional area. The SI unit of dipole moment, magnetic dipole moment is what? See here, SI unit of the magnetic dipole moment is joule per Tesla or ampere per meter squared. You should remember this. And if you want to find the unit of a magnetic dipole pole strength, so pole strength has a unit ampere meter. Okay, so I hope you have understood this. Now let us go for one special case. Now the case is that, try to understand this, when we cut a bar magnet along the length of the two equal parts, then its pole strength becomes up. So let us suppose this is a magnet, and if we want to cut from this, if we want to cut if you want to cut half like this, so if you want to cut from the mid like this in an axial direction, so what will happen? So when we cut the bar magnet along the length in a two equal parts, then its pole its strength become half. So let us suppose it's earlier the pole its strength was m by 2. So sorry, earlier its strength was m, so now its strength become m by 2 only. So when we cut like this, so our strength become like this. So what will happen? Magnetic dipole moment. So magnetic dipole moment is equal to what? See, as we have already discussed that the magnetic dipole moment is equal to pole strength, that is m by 2 into 2l. So finally 2 got cancel out, so ml. So what we have observed, that earlier magnetic dipole moment was m2ml, but now become ml. It means that new magnetic dipole moment is half of the older one, that is m by 2. So I hope you have understood. It means there is a reduction, reduced. So whenever you cut this magnet, so magnetic dipole moment will decrease. Magnetic dipole moment, dipole moment will become half, will become half. Okay. Now let us go for another case. When we cut a bar magnet perpendicular to its length into equal mm, parts, then its pole strength remains same. See, as we have already discussed that the pole strength depends upon area of cross section. So if you increase area or decrease area, so pole strength will decrease or increase as per the condition. But now what we are doing, we are cutting this bar magnet to a half. So its length become L, its length become L. What about the magnetic pole strength? So pole strength remains same. So new magnetic strength will be M into L. Why? Because earlier it was 2L. So now length become L. So new M also become half. So anyway, if you are cutting, what we have drawn the conclusion that when anyway either you are cutting vertically or either you are cutting horizontally the magnet, so its dipole moment, magnetic dipole moment will become half in both the case, but pole strength will remain same in this case, but in earlier case pole strength become half. Okay, so I hope you have understood this. So if you don't if you want to write this thing, so you can pause the videos and you can write it. Now let us go for next one. What is Coulomb's law of magnetostatics? So when we put our Coulomb's law, so we mean that we will take the analogous of the Coulomb. So we know that what is Coulomb's law. If there is a charge Q1 and there is a charge Q2 and the distance between this is R and both are positive, so what will happen? There will be a repulsive force. If you want to find the repulsive force, so what you have to do? F is equal to K Q1 Q2 by R square. We have already done this. So here the value of K is 1 by 4 pi epsilon naught Q1 Q2 by R square. So this is the force. This is how we can find the force. Now the thing is that if you want to find the if you put a magnet like this, see here, if you put a magnet like this is a magnet 1 and this is a magnet 2. This is north and south pole, so this has a magnetic strength M1 and this has magnetic strength M2. Now what will happen if it will keep, so they both will attract. So how with how much force they will attract, so the we need actual values. So what we need to do, we need to find a formula for finding a magnetic force between this. As we know that force force see here, force will be directly proportional force will be directly proportional to the strength of the product of the strength of the magnet. So let us suppose this as a magnet has it being of strength m1, this magnet has a strength m2. So force is directly proportional to the product of m1 and m2. Now again, another force is inversely proportional to the r square. So if you increase the distance, so force will definitely reduce. So it is like a electrostatic force also. So when we combine these two equations, so we are getting here force is proportional to m1 m2 by r square. Now if you remove proportionality constant, remove proportionality Nullity constant. So what we will find? So F is equal to mu naught by 4 pi m1 m2 by r square. So where mu naught by 4 pi is value, it has value 10 to the power minus 7. Okay, what is now mu naught? So 4 pi we understand. Mu naught is the magnetic permeability of a free space. How much the free space give the magnetic permeability, how much it permeates. If you change the space, if you change the area, so what will happen? If you change the environment, so it means that there will be a change in the force. If the permeability is more, so what will happen? Force will be more. If permittivity of the magnetic permeability is less, so it means that the force will be less. So this is what about Coulomb's law of magnetostatics. So this, from this we have got a important, very important formula, and this formula you should remember. Okay. Now next is a magnetic field strength due to bar magnet. You want to find a magnetic field strength due to bar magnet. So what is magnetic field strength due to bar magnet? So let us suppose the strength of the magnetic field at any point is defined as the force experienced by the hypothetical unit north pole placed at that point. So let us suppose you want to experience a force at this point. So what will happen? Definitely it will create a force at this point. So if you increase the distance, so maybe force will decrease. So everywhere you will find a magnetic field strength. Suppose this point has a magnetic field strength B1. This point has a magnetic field strength B2. So what happens? B1 and B2 may changes. Okay. Why? Because B1 is near, so B1 will be greater than B2. So ideally, what we need to understand, we need to define it. What is actually at a point? If you want to find a field strength at a point, this one. So let us suppose this is a distance. Distance is r, and we want to find a field strength here. Okay. So F is equal to mu by 4 pi F m1 m2. We know this. So how you will define this? See here. The strength of the magnetic field at any point is defined as the force experienced by hypothetical unit north pole placed at that point. So let us consider this magnet has a pole strength m, and another we will put here m. So let us consider m1 is equal to m and m2 is equal to 1. So if you want to find a force on this, so this force will be what? This force is equal to mu naught by 4 pi into m1 m2. So in place of m1, we have to put here m. In place of m2, the magnetic field strength is 1 divided by r square. So this force is itself become a magnetic field strength. When you keep any of the north pole having a magnetic field strength unit, then the force applied on this will become a magnetic field strength. So in place of force, you can write P, and this will be equal to mu naught by 4 pi into m by r square. So finally, if you want to find a field strength at any point at a distance r, so you have to use this formula. If you want to find a if you want a value, put the value of mu naught by 4 pi. So this will be 10, mu naught by 4 pi is equal to 10 to the power minus 7 wave per ampere, and this is the magnetic field. This is the magnetic field around which, if you increase the distance, so field distance will decrease the square times, because it is inversely proportional to the field strength. So I hope you have understood this field strength, right? Note, magnetic field is a vector quantity, and the direction of magnetic field is always uh, along which hypothetical unit north and would tends to move. Okay, so let us suppose this is a north pole and south pole. So the direction of magnetic field will be like this, like this. Got it? So it is coming out from the north always. Okay, outside. So I hope you have understood these classes. So it is enough for today.